So today we're going to be talking about adding and subtracting. So adding and subtracting rational expressions is just like adding and subtracting fractions. So let's go back and get back in our time machine, back to elementary and middle school. Did this. Okay. So let's say we have 13 over 30 plus 19 over 42. What do we need to have, or how do we add two fractions? What do we need to do?
The same denominator.
So we have to get a common denominator. And when we dealt with fractions, like any common denominator was usually going to be okay. We could get to the correct answer. When we deal with rational expressions, though, things are going to be potentially quite a bit more difficult depending on the common denominator you choose. So in particular, when we deal with rational expressions, we want to not just any old common denominator, we want the there's no greatest, least common denominator. The reason is that if you don't use the least common denominator, you will absolutely have to reduce at the end, and potentially you'll end up with a giant polynomial that'll be very difficult to factor at the end if you don't use the least common denominator. Now, that doesn't escape from the possibility of having to do some reducing still at the end, but it will never be as difficult as, if you didn't use the least common denominator. Okay, how do you find a least common denominator then? So if I have 30 and 42, how do we find the least common denominator there? What?
I know what it is, but I don't know. Wouldn't it be 2?
No, the least common denominator is going to be a number that's bigger than both of them.
So just add them?
Nope.
Multiply two numbers.
So multiplying them together will give you a common denominator. It will not necessarily be the least common denominator. What you want to do is start by looking at the prime factorization. So 30 is 2 times 3 times 5. 42 is 2 times 3 times 7. So your least common denominator is going to contain each distinct prime number that occurs. How many distinct primes do you see there? You should see 4, right? 2, 3, 5, and 7. Everybody agree? So that's our least common denominator is going to contain those primes. Now we have to figure out how many of each of these do we need to have. Okay? So the way to do that is we look inside of each fraction, the maximum number of times each prime occurs. And that's going to be how many we have. So if I look at the 2's, what's the maximum number of times 2 occurs? Well, it occurs total twice, but once here, once here. The maximum is 1, right? So we're just going to have 2 to the first. What's the maximum number of times 3 occurs? Just once, 1 in each fraction. So that's also going to need 1, 3. What's the maximum number of times 5 occurs? Still once. The maximum number of times 7 occurs? Once. So that is going to be our least common denominator, is 210, or 2 times 3 times 5 times 7. Now, what do I need to do then to make those common, or make 30 into 210? Well, 30 contains the 2, it contains the 3, it contains the 5, but it's missing the 7. So I'm going to multiply the top and bottom by 13 over 30 by 7. And then I'm going to look at the 42. We have the 2, we have the 3, we don't have the 5, and we have the 7. So I need to multiply the top and bottom of 19 over 42 by 5 over 5. Everybody's okay with that? Okay. So 7 times 13 is 91. And then 5 times 19 is 95. If I add 91 and 95, I get 186 over 210. And now I'm going to need to reduce, right? So when I do the prime factorization of 186, that's 2 times 3 times 31. 210 is, and I knew that already, right? We found that least common denominator. So when I reduce, I end up with 31.5. Does that jog some memories here? Okay. You guys ready to do some with rational expressions, or do you need another fraction example? Rational expressions it is then? Okie dokie. Let's get after it. All right. So let's start with something pretty straightforward. Say we have 2 over x plus 3 plus x minus 1 over x minus 4. We start by factoring the denominators. Can I factor x plus 3 anymore? No. So that's done. I'm just going to put a parenthesis around it to indicate to myself that it's done factoring. How about the x minus 4? Nothing more I can do with that either. So what are the distinct primes in my denominators then? How many do I have? I have 2. I have x plus 3, and I have x minus 4. Since neither of those can factor anymore, they're like a prime factor. How many times does the x plus 3 occur? Or the maximum number of times the x plus 3 occurs? Once. And the maximum number of times the x minus 4 occurs? Once. If I look at the first fraction, I have the x plus 3, but I'm missing the x minus 4. If I look at the second fraction, I have the x minus 4, but I'm missing the... So far, so good. Combine our numerator now. So I have an x squared. 2x and 4x is 6x, and negative 8 and positive 3 is negative 5. And then the denominator, I have to check at the end to reduce. I would need to factor the denominator anyways, right? So the denominator you really can just leave in a factored form the whole way through. Okay, so the addition is done. We just need to check to see if we can reduce. So are there 2 numbers that multiply to give me 5 and add to give, or I'm sorry, multiply to give me negative 5, give me positive 6? Okay, so those don't multiply to give you negative 5. So really you have 5 and negative 1 and negative 5 and positive 1 are your only 2 choices. Neither of them add up to give us the right thing, so there's nothing more we can do. It's common that you can reduce one of these at the end. It happens occasionally, but it's I would say 1 out of 10 times you run into something that can reduce a little bit at the end. It's pretty unlikely, though. Unless you didn't find the common or least common denominator, in which case you'll certainly have to reduce at the end if you didn't find the least common denominator. But you may run into bigger problems than that before the end if you didn't use the least common denominator. Let's do another. Sound good? Okay. Okay. So here's our problem. What do I want to start with? Factor the denominators, right? So how does x squared plus 8x plus 16 factor? What does that factor to? You guys should be able to tell me this without too much trouble. It's already taking too long if you're trying. Try harder. So that's going to add to give you 10. There you go. And the x squared minus 16? Very good. Our least common denominator now. What are the x minus 4? What's the maximum number of times the x plus 4 occurs? Twice. Again, you have to look at each fraction separately. 2 of those. And the x minus 4, once. Okay. So now let's go and make our common denominator. So the first fraction has 2x plus 4s, but it doesn't. The second fraction does have the x minus 4. So far, so good. Okay. So I'm going to FOIL. I'm just writing that because I'm going to skip showing the foiling step, but I wanted to write down that I'm doing it. Okay, so what I've written down here is wrong. What's wrong with it? This is the most common mistake I see students make with doing these addition and subtraction problems. Bianca? Nope. That was what our least common denominator was, right? You could write it as 2. That's fine also. It's hard to see, which makes it easy to happen. That negative sign applies to everything. So when we write this, we need to do that and distribute through. Yeah. Which again, like now I see that, but it is easy to forget to do that. In fact, guys, look for what the heck was wrong with that. I don't know. It would have taken a while, I think, before somebody finally saw that. It's easy to miss. And it is, in my experience, the most common mistake students make. Like even by the time test rolls around, I would bet 50% of students in a class like this will forget to do negative. Okay, so let's see. X squared minus x squared is 0. Negative 3x and positive 1x gives us negative 2x. Negative 3 and positive 20 gives us positive 17. And obviously, negative 2x plus 17 can't factor anymore. Answer. Oh, excuse me. So sleepy, guys. Okay. One more example, you think? Okay. So this one, I'm going to write it, write up the question, and then kind of give you guys a little bit of a head start to try it on your own, and I'll kind of fill things in as we go. So if you've made a mistake or you get stuck somewhere, like you'll get a little shove in the right direction. How's that sound?
Good.
Good? Okay. All right. Okay. This one has 3 fractions. Oh no! That's okay though. 3 fractions is not a big deal. You can kind of approach it the same way still. A little bit more to do, but not so much, not so bad. And again, I'm going to give you guys a little bit of a head start here to periodically be writing some stuff in so that if you're stuck somewhere, get halfway through and you start thinking you've made a mistake, it'll help you kind of go back and track through and figure out what's going on. And then we'll go through, I'll talk through the whole thing once I have the whole thing written out as to what I'm doing. But it shouldn't require too much explanation because you've been kind of doing it yourself along the way also. So it should be a quick explanation, but we'll walk through it here at the end. So again, really important that you are giving this a shot. You're trying it on some scrap piece of paper or in your OneNote folder or whatever. Just like give it a shot. Getting some feedback right now before you have to do it in the homework is really important. Makes a big, big difference, even if it's just like, oh, I figured out like that what I would try to do in the homework was not the right way to start it. Even if that's all you figure out, that like, hey, what my initial instinct was to start this was wrong. That's important feedback to get, right? Before you have to start doing a whole assignment. And maybe you figure out like, oh, I think I'm in a good spot. I did that pretty much all correct. You know, that's good information to have too. Or if you're somewhere in between. You know? But it's just not asking to do a whole lot. We're just trying this out. Well, you have 3x times x plus 3. You're good now?
Yeah.
Yeah, no problem. All right, you guys ready to kind of walk through this here? Okay. So we started by factoring. So x squared minus 9 is x plus 3 times x minus 3. 5x minus 15 is 5 times x minus 3. And x squared plus 3x is x times 3x. So I make my least common denominator. I have 4 distinct prime factors. I have a 5, I have an x plus 3. Time occurs is once. So the first fraction has the x plus 3 and the x minus 3, but doesn't have the 5 or the x. So I multiplied that one by 5x over 5x. The second fraction has the 5, doesn't have the x, it doesn't have the x plus 3, but it has the x minus 3. So I multiplied plus 3 to the top and bottom. And the third fraction doesn't have the 5, it has the x plus 3, but 1 by 5x minus 3 to the top and bottom. Okay, did that with that so far? Okay. 5x times 2x is 10. 3x times x is 3x squared, and then when I distribute that through the x, I get 3x cubed plus 9x squared terms. So there's only one thing with x cubed, so there's my 3x squared. 9x squared and negative 30 is negative 11x squared. I have the x term, so 90x. So I notice the numerator has the greatest common factor of x, so I can pull it out. And then the 11x plus 90 is factorable. There's nothing more I can do with that piece. By doing the checking if the square root e squared minus 4ac is a whole number. That's not a whole number. I know it's not factorable. It wasn't a whole number, so I reduce these and give my final answer. Denominator, though. There. What do you guys think? Quite a bit tougher than multiplying and dividing, right? It's a more complicated procedure, for sure. But that was the same way when we dealt with fractions back in elementary and middle school, right? Was adding and subtracting was much harder than multiplying there also. We're going to stop here.